Hey guys, happy Thursday to you. I'm being told this is the last assignment I can give you for the year. So as you can see, we're going to be doing the axle cap screw. We can tell a lot of information by this picture. We can tell that it says it's a hex socket head, 5/32 across flats. That means it's going to use a 5/32 Allen wrench. That it's 0.111 inches deep. This designation here, 1/4 20 UNC by 1 inch. That means that this is going to have a 1/4 inch diameter, 20 threads per inch, unified national coarse thread by 1 inch, meaning that from the underside of the head of the screw to the very end here, it's 1 inch. The best way to draw this is to draw the profile and to revolve it. So, as you can see, I've already got Inventor opened up here. I need to start a new standard IPT. And just wait for it to open. Maximize my window here. And I need to start with a sketch. I'm going to click on the XY plane, of course. And I'm going to start with a line from the center up. I am going to go 1.125 inches, or 1 1/8 inches. And it went crooked for some reason. Let me drag this back into place. Go backwards and try that again. Line. Center. Straight up. 1.125. Enter. I can come straight out. And it says that that needs to be 0.125. I'm going to hit escape on my keyboard to release me from that function. And I'm going to come back to grab the line tool again, and I'm going to do the same thing on the bottom. Come over 0.125 inches. Then I'm going to bring my line straight up. 1 inch. Okay, hit escape. Now I want to point out, looking at our dimensions here, we have this line coming out here. If we follow this red line down, this is a diameter. It's listed on here as diameter of 0.422. So what that's saying is that's half of the diameter from the center line out to the edge here. So I'm going to grab my line tool, pick up where we left off, draw a line straight out, and then I'm going to dimension just from the tip of the line back to our center line, and I'm going to make that 0.422 divided by 2, or 211. So I'll zoom in on this so you guys can see what we're doing here. It says here that this is a spherical radius of 0.236. So that means that it's a dome. So what we're going to use here, I'm going to come over to Create up here in the tool ribbon where it says Arc. Click down and we're going to choose a 3-point arc. We're going to click on the end of the one line. Click on the end of the other line, and now as we move our mouse or our cursor, you can see what we get here. What I want is I want it very close to being a straight line, but you can notice that it's a positive curve because it's showing a construction line going to where the center point of that radius or arc would be. If I come in a little bit, it flips over to the other side. So I just want it a little bit on that side, and I'm going to go ahead and type in 0.236. What that'll do then is automatically find the center point for that. And I screwed up and left a line off there. Let me go back, remove that. And what I left off was this little flat there, which was a little line that comes up 0.031. So we need to add that. Go back to the line. Click on the end. 0.031. Hit escape on the keyboard. Now we can go back and get the 3-point arc. And go from the end of that line, the end of that line. And so it's a little bit on the positive. Type in 0.236. There we go, that looks better. Finish that sketch. And then I'm going to come up, click Revolve. And since it's already, you can see it's highlighted blue. It already found the profile because there's only one profile there. The only thing left to choose is the axis. And we're going to choose that to be that center. Click OK. The next thing that we're going to do, put the hole in the top for the wrench. This 6-sided hexagon hole. So we're going to put a sketch on the top flat spot of that. Come over, click Create, click down on the rectangle, come to the bottom for Polygon. And we want to make sure that that is highlighted to be 6 sides. And click on the center. Come out somewhere and click it. Click Done. Choose Dimension. Click on one flat. It'll give you the length of that line. Move down. Click the opposite one, and it'll allow you to get the dimension between the two. And you can go ahead and type in the fraction of 5/32 of 1 inch there. I'm going to finish that sketch, and then we are going to extrude that hole. But we want to cut it. The distance on that will be 0.111. Click OK. And as you can see now, we have the hole in the top of it for the wrench. The only thing we have left to do, or the next thing we need to do, is to put this 45 by 45 degree by 0.03 chamfer on the bottom. So we're going to come up to the tool ribbon, find the chamfer tool, and come up here to where it says distance. Or no, over here we have distance, distance and angle, or two distances. We're going with distance and angle. The distance needs to be 0.03 and the angle 45. So we come and click on the edge or the corner, and okay, I must have accidentally clicked on the face first, and it wouldn't have mattered. Okay, so it's highlighted to be face. So I click on the bottom, and then it automatically changes to the edge. Then I click on the corner. Click apply, and close it out. And then we have our shape. All we need now is our threads. So the next thing we do is come up here to the modify section, find the thread tool, and then choose the section. Come on, open up. There we go. Okay, so the thread window opens up. The face is highlighted. It wants to know where we want to put the thread. And we want to put it on the face of the screw. Okay. We can expand on this right here and click on where it says specification. It already recognized that it's a 0.25 diameter, and that's where we could choose the different thread options. We're going with 1/4 Unified National Course, and we could change left hand and right hand thread. Yeah, you can't really see the difference there, but it should be a right hand thread. We're going to click apply, close that out, and that is our axle cap screw to hold our wheels onto our train body. Get two pictures of this, one with the top so I can see the hole, and then one with the bottom with the chamfer on it. Put it in a Google Doc named Axle Bolt, and share it with me. And that's the end of it. Thank you very much, guys.